The human brain can easily trick you into thinking that things are different from what they really are. Today's video is a little bit different as, along the way, we're going to put your brain through a series of challenges and puzzles. See how many you fall for, and see how easy it is for your own brain to fool you. Number 10. Making sense out of gibberish. Listen to this soundbite from the Franklin Institute. It's gibberish, right? Well, that's actually a sentence which has been transformed into so-called computer speak and sounds like complete nonsense. Now, listen to the real sentence.
The Constitution Center is at the next stop.
And try listening to the gibberish again.
The Constitution Center is at the next stop.
Does it now make sense?
The Constitution Center is at the next stop.
That is exactly the same soundbite. Your brain is now just using the information it gained when we told it the real sentence to miraculously make sense out of the gibberish. Go back and listen again if you don't believe me. Human brains are incredibly adept at making sense out of nonsense if they have prior knowledge that they can use to piece things together. This ability is linked to why humans so often see faces in inanimate objects. The brain seeks familiarity and is prepared to bypass complications to make sense out of confusing stimuli. Similarly, our brains can make sense of words not even spelled correctly, so long as the first and last letters are in the right place. Number 9. False memories. Can you trust your memory? Well, maybe you shouldn't.
Memory can change the shape of a room, it can change the color of a car. And memories can be distorted. They're just an interpretation, they're not a record.
Studies have shown that it's surprisingly simple to trick the human mind into accepting memories that have been completely fabricated. In 2002, Kimberly Wade of the University of Warwick carried out an experiment in which she showed participants childhood pictures of them in a hot air balloon and asked them to describe the experience. Half of the volunteers were able to offer details about what it felt like and conversations they had at the time. But here's the kicker, the pictures had been edited. None of the participants had ever actually been in a hot air balloon. Wade's explanation for this is that our memories are malleable because there is simply too much information to take in. When we struggle to properly recall an event, our brains fill in the gaps with concocted memories based on information that we already know about the world. Number 8. The brain can't understand randomness. In your mind, picture flipping a coin 100 times in a row and imagine how it would land each time. Make a note of it. Heads, tails, heads, heads, tails, and so on. If you were to compare your imaginary results to results made by actually flipping a coin, you would instantly be able to tell the difference. The real results would be much more sporadic, and would be much more likely to feature, say, 4 or more heads in a row. This is because it's statistically improbable that 4 heads in a row would occur, so humans would never think to list that possibility in their hypothetical results, whereas in reality, it is entirely plausible that this could happen. Because of how the brain struggles to understand randomness, music streaming site Spotify had to change its algorithm so human listeners wouldn't perceive patterns within the order of the songs played on shuffle. Before this, listeners had been complaining that the site would occasionally play the same song a few times in a row, as should be expected to happen with a truly random shuffle function. Number 7. Change blindness. The human brain is alarmingly blind to change that is happening right in front of us. You'd think you'd notice if the person you're talking to changed halfway through your conversation, or if a key part of a picture you were looking at suddenly disappeared. But studies have shown that this may not be the case. Check out this demo from gocognitive.net. Look at this image closely and try to figure out what changes after it flickers. Didn't catch that? Look again. The majority of people running this demo fail to work out that it's the shape of the moon that changes. Try another example. Still struggling with this one? The key to change blindness is disruption, even if the brain is only disrupted for a second. So let's see if it becomes any easier to spot the change when we remove the disrupting flicker in between the images. All of a sudden, the difference becomes much more obvious. Make a change to a scene while an individual is distracted, and it's unlikely they would notice that anything has been altered at all. This is because the brain's memory functions are limited and cannot perfectly capture every element of an image in order to notice how it changes. The brain therefore assumes that everything stays the same, even if major changes have taken place. Number 6. Alien hand syndrome. Imagine if, instead of simply tricking you like it's doing in the rest of this list, your mind was actively trying to attack you. That's kind of what it's like for those who suffer from alien hand syndrome, a rare neurological disorder that causes limb movement without the sufferer being aware of what is happening or having control over the action. There have only ever been 40 to 50 recorded cases. One sufferer, 55-year-old Karen Byrne, developed the condition as an unforeseen side effect of surgery to control her epilepsy, her left hand would repeatedly try to slap, punch, or undress her. The condition is caused by faulty communication between the brain's left hemisphere, which controls the right arm and leg as well as language skills, and the right hemisphere, which controls the other limbs and is responsible for spatial awareness. In Karen's case, her epilepsy treatment involved the surgeons cutting the corpus callosum, a brand of nervous fibers which keeps the two halves of the brain in constant contact. You can live with these fibers cut, and it is an effective treatment for epilepsy, but it can also lead to this bizarre condition. The condition has also been known to occur in those suffering from strokes or Alzheimer's. Number 5. Room for dessert. You know that feeling after you've just had a gigantic meal? Your stomach aches, you're exhausted, and you feel like you're never going to be able to eat again. But then someone suggests dessert, and all of a sudden you're ready for round 2. This phenomenon doesn't really make any physiological sense, as it sees the brain overruling what the digestive system is telling it. A human being has an incredibly complicated digestive system, which controls both food intake and appetite, and sends signals to the brain when you're satiated. Yet, the brain is able to completely override it, just because you've seen that there's a particularly delicious-sounding chocolate cake on offer. According to psychiatrist Dr. Nora Volkov, this is because the brain's pleasure centers, which activate when you eat or sometimes even just think about sugary desserts, are more powerful than the stomach's pain sensors that tell you when you're full. Number 4. Phantom limbs. Approximately 60 to 80% of people who have had a limb amputated experience the chilling sensation of a phantom limb. This is when amputees retain a perception of their missing limb and feel pain, itchiness, heat, or aching where it used to be. The sensation can be so severe that one sufferer described it as if my missing hand is being crushed in a vice. Occasionally, the pain is worsened by stress, anxiety, or even changes in the weather. Sufferers of phantom limbs have been tested using MRIs, and scientists have proved that the parts of the brain associated with sensation in a certain part of the body light up as they would if the limb was still there. Basically, what is happening is that the brain continues to receive signals from the nerve endings that originally supplied signals to and from the missing limb. It is difficult for the brain to adjust to such severe changes in the body, and so the sensory information gets a bit confused. Number 3. Optical illusions. Everyone loves an optical illusion. Take this one, for example. The segments seem to wave and move about despite it being a completely still image. Or this one. The two dots in the middle of the patterns are exactly the same size, despite it appearing as though the one on the right is bigger. Then there are the illusions that split opinion. In 2015, the internet went into meltdown over this seemingly unassuming dress, and the question of whether it was blue or black or white and gold. It's black and blue, by the way. Similarly, in 2016, Instagram was set ablaze with discussions of users not able to see that this girl's super shiny and oily legs are actually just splattered with white paint. But what's going on in your brain when it sees optical illusions? Obviously, it depends on the type of illusion in question, but the running theme is that they use color, light, and patterns in ways that the brain struggles to process, because the images you're seeing don't seem to make sense. The brain therefore fills in the gaps with motion, size differences, and colors that aren't actually there. Number 2. Quick thinking versus slow thinking. Put simply, the brain has two systems of thinking. Quick thinking is how your brain draws immediate conclusions, e.g., this person is feeling happy, or 1 + 1 = 2. Quick thinking involves very little effort or concentration. Slow thinking, on the other hand, kicks in when we are faced with a problem that requires a lot more working out. For example, 21 × 16, which only mega geniuses or calculators would be able to figure out instantaneously. When utilizing quick thinking, the brain often takes shortcuts to provide an answer, even if that isn't necessarily the correct one. In doing this, the brain tricks us into making silly mistakes. For example, if I were to ask you the simple question, how many of each kind of animal did Moses take on the ark? Your quick thinking system would most likely lead you to the answer 2. But had you engaged slow thinking instead and really thought about the question, you would have realized that it wasn't Moses, but Noah who built the ark. This example is known as the Moses illusion. Try another example. You buy a notebook and pen which cost $1.10 in total. The notebook costs $1 more than the pen, so how much does the pen cost? Chances are your first thought is 10 cents, even if you then think of the correct answer 5 cents afterwards. This is because 10 cents sounds like the simpler solution, so your quick thinking system will offer you that first. Number 1. Rubber hand illusion. The rubber hand illusion is an intriguing experiment that shows just how easy it is to confuse the mind. In the experiment, a fake rubber right hand is placed next to the participant's real right hand, with a towel used to cover the elbow. As the participant focuses on the rubber limb, the scientist simultaneously brushes both the fake and the real hand until the brain accepts both hands as real. The participants' pulse is monitored to see their reaction when the scientist then runs a sharp knife over the fake hand. Their heart rate very suddenly increases from the threat of the knife, as much as it would have done with the real hand. Although it would just appear to be a cool party trick, the rubber hand illusion is actually an important tool for understanding how sight, touch, and proprioception, the sense of body position, work together to create a convincing feeling of body ownership that is so strong that your brain can be tricked into thinking you have two right hands. Thanks for watching, guys, and I hope you found the video interesting. Let us know what you thought in the comments below. Were you tricked by the Moses illusion? What colour do you see the dress as? And as always, don't forget to like and subscribe.